Hey there kids, welcome to another 5th grade math video for Eureka Math. This is for Module 2, Lesson 11, homework. And the objective today is to multiply decimal fractions by multi-digit whole numbers through conversion to a whole number problem and reasoning about the placement of the decimal. So go check out the video for the problem set that I posted before. It's got a great connection to like old school math. Parents and teachers, you will love that part. Basically, this is just like, why can we just count the places and then plop that right in the answer? So this is why. And so today we're going to have to use these little thought bubbles to show our thinking and so that you can prove that you understand what's happening. So it's really just easier if we do it. So we're going to jump right in. The directions say estimate the product. That's what we're going to do first. Solve using the standard algorithm. That's what we'll do second. And then use the thought bubbles to show your thinking. Draw an area model on a separate sheet if it helps you. Doesn't really help me too much. You are certainly welcome to do that on your own if you want to. So when we get started here, we want to make things as easy as possible. Don't make this problem really hard. Just try to get, again, about the right number of place value positions. So if I said 2, drop that all off entirely, times 12, I would end up with roughly 24. And again, it's just about how many digits will I have in my answer. So we're looking for a 2-digit number, something less than 100, greater than 9. And so then we have our first opportunity to show our thoughts. So think, 2.42 times 100 is going to make 242. That's the move the decimal out by multiplying by 100 step. So you're not actually going to do it in the standard algorithm. You're going to leave the decimal there, but you're going to think like this is just 242. Okay? So just think about it and then do the standard algorithm. So you estimate, now we use the standard algorithm. Pretend that the decimal is not there. So it's nice and easy, low numbers today. Back to simple calculations. 2 times 2 is 4. 2 times 4 is 8. 2 times 2 is 4. Yay. You should know by now that for row 2, it's your second partial product. It's really 10 times the top number. So hold this place with a 0. 1 times 2, 2. 1 times 4, 4. 1 times 2, 2. Don't worry about the decimal. Add up your 2 partial products. 4, 10, carry that over, 8, 9, 2. So we have our 2904. But this is where you have to start thinking about the answer. Think. 2904 is 100 times too large because if I shifted my decimal out and I was using 242 ones, then my product is too large. So what's the real product? Now you're going to do the divide by 100 to put the decimal back in, and you get 29.04 as your actual answer. So it's a super detailed way to show your thinking. Okay, now down below you're not going to have all their help, so this is your opportunity to show that you know what's happening. So let's take our whole number 4 and multiply it by 40, and 4 times 4 is 16 plus the 0, so we should get about 160 approximately for our answer. So here's your think time. Okay, now in the thought bubble you should take your 4.13 and we want to get the decimal out. So what would we do to get it out? You would multiply by 100. If you do that, you're going to get 413, which is what we're going to pretend we have as we use the standard algorithm. Okay, now your next thought is going to be about your answer is too big. Answer will be too big. And it's going to be how big? 100 times too big. Too big. Okay, so don't forget that as we work on our standard algorithm. 7 times 3, 21. Carry. 7 times 1, 7 plus 2 is 9. 7 times 4 is 28. Next partial product. Done with the 7, move to the 3. 3 times 3 is 9. 3 times 1 is 3. 3 times 4 is 12. Got to know those facts. Add up your partial products. 18, 9, 10, 11, 12, 4, 5, 1. But 15,281 is too big. How big is it too big? It's 100 times too big. Okay, so then you're going to divide by 100. So divide by 100 to get the real answer, which is going to be right here, 152.81. Comparing with 160, then you've got a 3-digit answer, 3-digit answer. 152, pretty close to 160, good enough. Okay, so that is the whole idea behind today's lesson. And so now you get to practice without the thought bubbles kind of getting in your way, but you still have to think it, okay? So solve using the standard algorithm, and you can show the decimal, just don't worry about it yet. Okay, so multiply. 3 times 3, 9, 3 times 0, 0, 3 times 2, 6. Don't worry about the decimal. Go to the 1, hold this 0. 1 times 3, 1 times 0, 1 times 2. Add your partial products, 9, 3, 6, 2. Remember that if I was to remove this and work with 200 300ths but in unit form with no decimal, then I would have to put it back in. So if it's a times 100 to get the decimal out, it's divided by 100 to put the decimal back in. Put your decimal in, that's your final answer. Some kids will say, but it's right here, it's coming down. No, that's not what's happening. Go watch the previous video for lesson 11 problem set, and you'll see what happens when you have decimals in your second factor too, because that's going to mess you all up. What if I had a decimal here? Where does the decimal fall? See what I mean? So it's not just lining them up, we're calculating it. Do this one, 53.16 times 34. Okay, again, standard algorithm, you've got the decimal in there, but we ignore it. Keep everything lined up in place value positions very carefully. Here we go. 4 times 6, 24. This is 4 and 2 is 6. This is 12. 4 times 5 is 20, plus 1 is 21. Next row, hold that 0, get over to the tens place. 3 times 6 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. 3 times 5 is 15. Add your partial products. We get 4. 8 and 6 is 14, carry the 1. 4, 5, 6, 7. 9 and 1 is 10, carry the 1. 5, 6, 7, 8, and a 1. But this has to have, we have to have a decimal in our answer. Remember, if we are pretending it's not there up here, we got to put it back in. If it takes, you take it out by multiplying by 100, divide by 100 to put it back in. Okay, so 2 places here, 2 places here, 2 places here, 2 places here. Final answer. Set this one up. 371.23 times 53. Okay, and again, standard algorithm, the decimal's there, but we ignore it. We multiply and ignore. 3 times 3, 9. Then 3 times 2, 6. 3 times 1, 3. 3 times 7, 21. Carry the 2 over. 3 times 3 is 9, 10, 11. Lots of digits here. Keep them lined up carefully. Done with the 3, hold the 0, get to the next tens place, start multiplying. 5 times 3, 15, carry the 1. 5 times 2 is 10, plus 1 is 11. 5 times 1 is 5, plus 1 is 6. 5 times 7 is 35, carry the 3. 5 times 3 is 15, 16, 17, 18. Add your partial products together. 9, 6 and 5 is 11, 3, 4, 5, 6 and 1 is 7, 6, 9, 1. 2 places here, 2 places here. Put your comma in, because when you have really big answers, and we do have a lot of digits here, you have to, every 3 places, you have a new period. So it's going to help you say this properly. 19,675 and 1900ths. Okay, now for this one, you could put either one on top. It really doesn't matter. Just for consistency, I'm going to have the 1.57 on top, 432 on the bottom. You can do either way. 2 times 7 is 14. 5 times 2 is 10, plus 1 is 11. 2 times 1 is 2, plus 1 is 3. Okay, second row, done with the ones. Hold that. Move to the tens. 3 times 7 is 21. 5 times 3 is 15. 16, 17. Carry the 1. 3 times 1 is 3 plus 1 is 4. Now you get to practice your third partial product. Remember that you have to have 2 zeros in line 3 to get you over to the hundreds place, so you can multiply with the third digit in the hundreds place, the 4. 4 times 7, 28. Carry the 2, use it here. 4 times 5 is 20, plus 2 is 22. And 4 times 1 is 4, plus 2 is 6. Add up your partial products. 4, 2, 15, 16, 17, 18, 4, 5, 6, 7, and 6. 2 places here, 2 places here. 678 and 24 hundredths is your answer. So that's a lot of good practice using the standard algorithm with decimals in your factors. All right, so for the next activity, you are supposed to use the whole number product right there, and place value reasoning, everything is connecting to place value, to place the decimal point in the second product, and then explain how you know. So look what they have done for you. They took your factor 36 by 134, and they gave you the answer, 4,824. Look, it's the same factor to begin with. It's the same digits, except you now have a decimal. So putting the answer on the line, you know it's going to be 4824. You should be able to write that. But now where do you put the decimal? Okay? No decimals here. It's ones times ones for ones. But this is ones times what? Hundredths. So 2 places to the right here in your factor, therefore 2 places to the right in your product. Okay? So basically, if you compare the size of these factors, 1.34 is 1/100th of 134. So it's much smaller. So your answer should be like 100 times smaller, or 1/100th of the answer that we had previously. Okay? So the answer is, you can say divided by 100, divided by 100, so that you can end up with your proper decimal placement. Sorry, you probably can't see that. There you go. Okay? Same thing here. Look at your first factor. Look at your second factor, 2674. So 2,674, 2674, 26 and 74 hundredths. So what happened here? Our answer is going to be 224,616. All these digits, but where do I put the decimal? 2 places in our problem, 2 places in our answer. Okay? So the answer will be 1/100th of the original answer. Okay? So we're dividing it by 100, just like they did with our factor. Next one, 19 is the same. Look, they switched it around, but they can do that. 3211, but watch out. Here they only have tenths. So what's our answer? 61009. But here we only have tenths, so here we only have tenths. Okay, answer will be 1 what? 10th of original. So that's what they want you to think about. They want you to start paying attention to the size of the factors and where the decimal is. If you pay attention to where the decimal is, it'll be really helpful for you. And do click subscribe if you are having nothing to do for the next few minutes. Click subscribe and come back again. All right, a slice of pizza costs $1.57. How much will 27 slices cost? It's a pretty good price for a slice of pizza. So you're going to take your, don't be afraid to multiply with decimals now. Take your decimal number, put it on top. It's got 3 digits, times 27. Set it up to multiply. Just use the standard algorithm. Pretend like the decimal's not there. 7 times 7, 49. Then we have 35 plus 4, 39. and then 7, 8, 9, 10. Don't put any decimals in. Don't put decimals in your partial product. Move on to the next one. Hold this with a 0. Now we're in the tens place. 2 times 7 is 14. Carry the 1. 2 times 5 is 10 plus 1 is 11. Carry the 1. 2 times 1 is 2 plus 1 is 3. Add up your partial products. 9 to 4 is 13. Got a 2 and then a 4. But don't forget, if I have 2 places here, I should have 2 places here. And this is for money, so it's $42.39 for the 27 slices. Don't forget to always have words in your answer for word problems. Next one, a spool of ribbon holds 6 7/75 meters. A craft club buys 21 spools. So what is the total cost if the ribbon sells for $2 per meter? So let's find out how much ribbon we're going to have. Take your 6 7/75 meters. Don't forget to label everything so you can keep track of what it is that you're trying to find. By the 21 spools. And then find out this by pretending the decimal is not there. So use the standard algorithm. 1 times 675, well, you know it's going to be 675. 1 times 5, 1 times 7, 1 times 6. Move over to your next one. 2 times 5 is 10. That 0 goes there. The 1 goes up. 2 times 7 is 14. Plus 1 is 15. 1 goes up. 2 times 6 is 12. Plus 1 is 13. Add up all your partial products, 5, 7, 6 and 5 is 11, carry that, and we get 4 and 1. But don't forget the decimal. Now, what do we have? Is this money? Is it meters? Is it spools? Okay, it's all the ribbon on, it's all the meters of ribbon times the 21 spools. So this is 141 7/75 meters of ribbon in all. Now, what's the total cost? So I need to take my ribbon and multiply it by $2 per meter. Now this is going to be 2 ones, so I don't have to have any decimals. I can just put the 2 there. And it's money, so you can put a little dollar sign. We just don't want to forget that it's money, because this is length and this is money, and we're looking for cost. So final answer. Oh, but we won't have multiple products, so I don't need that down there. Multiply. 2 times 5, 10. Then we have 14 plus 1, 15. 2 times 1 is 2 plus 1 is 3. 4 times 2 is 8. And 2 times 1 is 2. Trying to keep things lined up. I got a little off there. But it's hundredths times ones, which makes hundredths. So 2 decimal places here, should have 2 decimal places here. So the cost for all the ribbon. The cost for all the ribbon is $283.50. Okay, label everything and circle your answer. Okay, last part of this. If the club uses 76 54/100 meters to complete a project, how much ribbon will be left? So basically we've got all this ribbon. And this is just kind of keeping you honest. Like, kids get so dedicated to what we're doing. It's like, we're multiplying, we're multiplying, we're multiplying. And then they're like, what is this? Okay, well, we've got a total, and we use this. So this one is a subtraction problem. They're using it, and what do you do when you subtract? You have to line up your decimals. Be very careful. We're not multiplying here, we're subtracting. So you take your total amount of ribbon and you take what they used to find out what's left. Simple subtraction here. 5 minus 4 is 1, 7 minus 5 is 2. No regrouping necessary until you get to the ones place. Don't flip it around. We only have 141 meters. So from here, go next door, take 1 and give 10. 11 minus 6 is 5. 3 minus 7, don't flip it around, just go here, take 1, give 10. 13 minus 7 is 6. Label this meters, it's 65 and 21/100 meters is left. And you're done. Yay! not too bad. Not too bad. I hope this is helpful. Click subscribe, come back, and we'll see you on the next video. Goodbye for now.